I had sent an email to everybody with the link to the videos, with a link to the textbook, which is free. And I gave you the first homework assignment that's due by midnight Sunday. Since again, some of you are waiting to get access to Blackboard. So I've given you everything you need to keep up with the class so you don't fall behind. That's important. I don't want you to fall behind in the class because you aren't able to register.
Sorry to interrupt you, Dr. Littman. I didn't got any email because I registered for this class yesterday only.
Well, so yeah, so is that Saeed?
Yes, Sayyid Mudassir Ali.
Yeah, so I sent you the link to the video though, right?
Yeah, I got that.
So if you would just reply back to that this morning, and I'll reply back with the email I sent the other day. Although you will have access to Blackboard, so you already have access to all the stuff, but go ahead and send it to me anyways, so I can get you the exact email everybody else got. That way you get signed up on Slack.
Okay, sure.
But so the whole reason I'm doing that, those emails, is because not everybody is in Blackboard. So ideally we get everybody on Blackboard as soon as possible, so I don't have to break the class out into these different modes of delivery. But for right now, it's more important that you don't fall behind than it is for it to all be on Blackboard. So I don't want us to get into a situation of, oh, I wasn't able to register for the class until week 3, so I didn't have to turn in any homework. That's not going to fly. Because at this point I've issued several letters, for immigration, so saying that you're allowed to start the class a little bit late so they can take that into consideration for your visa. And part of the deal here between you and me is that I write that letter and you keep up on the class right now so you don't make my life harder. So in any case, everybody should be completely done with the quiz, and I'm only going to take answers that were delivered within a reasonable time after the 8:20 deadline. I saw several of you popped in around 8:15 a.m. so you didn't have a lot of time for that quiz. Remember, class starts at 8, and you can't blame it on traffic that you were that you were running late. So get to class on time. I mean, I'm already running classes shorter than usual. So because the class is kind of a hybrid online and face-to-face format, since you already have all the units on Blackboard. So a lot of the course you're going to be doing with your own research and stuff like that. And I'm supplementing it with these lectures. So, our lectures are not a major time suck for you twice a week to be on for an hour and a half. We're going to stay until shortly after 9 today. I have a appointment I need to get to about 20 minutes away by 9:30, but we'll cover the rest of this information and make sure that you have everything you need for the homework that's due on Sunday. Let's see. All right, so question just came in. Can you please give us an overview of the assignment and how it should be presented? So the assignment that I emailed about, here, let me bring it up. Yeah, let me just do this. I can bring it up on my email. I just don't like to bring my email up when I'm in the middle of sharing my screen. So give me a moment. I might need to have it on a different computer. I don't know why they don't sync very well. I think this is. Nope, that's not it. Okay, here it is. And actually what I'm going to do here, just real well. Actually, hold on. So it's Syed Monuddin that didn't get the email. Is that correct?
So, Dr. Littman, I got an email of your the Zoom link, and
All right. Wait. Just what's your full name so I can find your email address and send this to you real quick.
sure, SYED.
Yeah, I got that.
Okay.
Even I didn't got Dr. Mike.
Because I have multiple Syeds. I have Syed
Yeah.
Ali, I have Syed Monuddin, and I have Syed Mudassar Ali.
Oh, we can type in chat box as well.
All right, yeah. Put your email address in your in the chat. I'll send it real quick. Okay. Yeah, Monuddin, that one. Okay. Then let me. All right, you should have that email now. I just forwarded it to you.
I got it. Thank you.
All right, let me start sharing again. All right, so this is the email that I sent out, and some of you may have actually gotten it more than once because I tried to cover all the different email addresses. That's why I said it's easier if we get this all on Blackboard, and even more importantly, if I get you all on Slack, which I'll talk about here in a second. Because trying to corral everybody who might be in the class, because we have some of you who are registered, some of you who are just about ready to register, and some of you who are still waiting on your visa stuff to get finalized. They can give you a phone number so you can register. So we have a whole bunch of different people here, and so I'm trying to make it fairly easy for me to communicate with you. So I'm copying email addresses from all over the place. So some of you may have gotten this more than once. But in any case, I gave you a link directly to the Blackboard course, but you're only going to be able to access it if you are already in the class. So I know for a fact that not all of you have access to the class yet. So that's why we're doing this email crap. Then I gave you a link. Here's the YouTube link. And this is the playlist for this class. So this same link will always get you to the collection of lectures for this class. So today, when we're done with class, I'll upload it. I might not upload it until this afternoon, since we're going to be, I'll be running out real quick to get to my appointment. But actually, you should have gotten it, Syed SC. Isn't this your email right here?
Yeah, it's fine.
That's your Gmail.
Got that. Yeah, it's Gmail.
So did you get it?
No, on Gmail I'm getting, but not on Outlook.
Yeah. Right now, you're just going to get it in whatever email address I can grab of yours. So as long as you're getting it somewhere, that's okay. All right. So again, this is the playlist for the YouTube videos. This link will always stay the same. And I'll always just upload the videos there. So if you didn't see the lecture on Monday, which probably would have made today's quiz fairly rough, maybe not as rough as the people who showed up 2 minutes before the quiz was due, but rough nonetheless. You could always go and watch that lecture. Here's the link to the Zoom class that I put in there. And then again, this is on Blackboard. So the first assignment, which is due midnight Sunday. And again, if you are able to turn it into Blackboard, submit it to Blackboard. But if you don't have access to Blackboard yet, email it to me just like you just did here. So the assignment is to read chapter 1 from the book, and here's a link to the book. It's a legal PDF to the textbook for the class. So read chapter 1 and then answer these questions from page 60. Well, starting on page 60. So question number 1, 3, 7, 8, 9, and 36. And that's questions from chapter 1. The format you submit those to me in, I don't care as long as I can read it. So whatever format's appropriate for those questions, whatever's most compatible, you know, I'm not picky about format. I just want to make sure that I understand what you're trying to tell me. So however you best think you can answer those questions and make me understand that you understand it is perfectly acceptable to me. Let's see. So is that clear what I'm asking for the assignment? You're answering
Yes.
questions from the book. Now, I'll throw a little curveball in there. Keep in mind that, so I don't want to say that the question was a dumb question, because it's an appropriate question to ask. What format do you want stuff in? Because other teachers might be picky about stuff. So always ask, always make sure that you understand what format your teachers want. You will find pretty quickly that I am extremely laid back. I don't care about any of the formatting and stuff like that. You're not English majors, you're not writers, you're computer scientists. So get it to me in a format that I can read. And if you can read it and I can read it, I'll be happy, is the punchline. The one thing that I am a stickler about, and I mentioned it last class, I'll mention it again today, is that the work you submit is your own work. Okay, and really this is for your own good, you know. So if you do have some writing stuff that you turn in and you have taken stuff from another source, give them credit. Put, reference where you got the information from, then that's okay. Now, I would say you probably should not have a humongously high percentage of your paper be copied from some other source, and just because you gave them credit, it's fine. I should see some of your own words in there as well. But what I'm really getting at is I want you to make sure that anything you're doing ethically. So if you submit an assignment to me and you're using other resources that other than your own mind, that's okay. Just make sure you let me know that you've done that, because I almost promise you I'm going to figure it out anyways, that you did it. And we will be much better friends if you tell me where I can find it, as opposed to me finding it and you not having told me about it. Okay, so do the work on your own. You can use internet resources, just make sure you give them credit. So that's what I'm a stickler about, is that the work should be your own work, not so much the format. All right, questions about any of that stuff? All right, and then the last thing is we use Slack for communication. And let me actually put, so everybody who received this email the first time around would have gotten an invite from Slack to come and create an account on our Slack channel. So this is Slack. And we keep track of, I have a whole bunch of channels in here and we do direct messaging and things like that, but I created a channel specifically for this class, CSC540 spring 2022. So I expect all of you to be in that channel. You should all see a message when I type a message here. If I type in a message, all of you should get a notification saying that there's been something put into this channel. So this should be a very convenient and reliable way for me to communicate with people. I'll go ahead and add Syed. So Syed, you should have just gotten an email invite.
Dr. Littman, this is Syed Moinuddin. Can you please
Yep.
add my email address as well, please?
Didn't I just do that?
No, that's a different Syed.
Different Syed. Okay.
Yeah, I'm Syed Moinuddin.
Okie dokie. This. What am I doing? This chat.
I think on the top, add people.
Do this one. There's a whole bunch of emails here. Was this you?
No.
All right, well, let me send it to that one too anyways.
One more time.
Yeah, I got it. So this one's you.
There you go.
Okay. So then. Look at this. I'll just forward it to that other address anyways. All right. So I just forwarded the email to a couple other addresses as well, just in case. But in any case, all of you should have access to the Slack channel. And at the very least, I would assume that at least 10 of you, hopefully close to 14 of you, got that email from me the other day. And I wrote down here, finally, I use Slack for communication, yada, yada, yada. I mentioned I might even put extra credit crap on there. So there was a risk I was going to put something related to the quiz on there today. But I also gave you something to do in the Slack channel. So post in the Slack channel what your favorite food was to prove you had access to it. So out of 14 people, let's go and take a look here. We had 2 people that listed what their favorite food is. Okay. So one of 2 things are true. Well, one of 3, but I think only 2 of them are most likely true. It is possible you didn't get the email. That's only for maybe a couple of you. A majority of you got that email. You need to be checking your email every day, at least once a day, multiple times a day, preferably. Okay, because I will send you stuff electronically. You need to read the emails and follow the instructions in them. All right, because it won't be a excuse to say, oh, I didn't see it or I didn't read it or whatever. Okay, that email wouldn't have taken more than a minute or 2 to read, and it would have only taken 2 minutes to sign up for the Slack thing. You got a link in your email you just clicked on. So the fact that only 2 out of 14 of you were able to write down what your favorite food was in that channel is pathetic. So do better. You know, and I think I saw just in looking at my email a second ago that I think I only got 7 or 8 emails for the quizzes. Let's see what I actually get. I got 1, 2, 3, 4, 5. I ended up with 10. So that means four people didn't even do it. But you know, whatever. So you got to be better at that stuff, especially as computer scientists. You need to be good at electronic communication. All right. So in any case, all of you should be creating your Slack account. You should set up your notifications so that if I post something in there, you get notified that there's something new in Slack. In fact, there's even a good chance that I will put a message up between today and our next class on Monday with some sort of extra credit piece of information that the very beginning of class, you'll just have to let me know what that clue was that I only put on Slack, proving that you are reading Slack. All right, should not be a major hard thing for you to do. You can put the apps on your phone, you get notifications just like it's a text message, all that stuff. And I use Slack in all of my classes. All right, so punchline from all this, everybody knows where they can watch the videos from class. Everybody knows the Zoom link. Everybody knows that we meet on Monday and Wednesday mornings from 8 to 9:30-ish, let's say. But 8 a.m. is when we start, and you should be here at 8 a.m. because I'll do quizzes right there at the beginning, and you don't want to miss that. That's I didn't catch that. Say it again. No, somebody just said something. I thought it was somebody asked a question. I'll keep going. So you got the Zoom link. Make sure you're at class by 8 a.m. And class will end around 9:30, sometimes a little bit earlier, but right around 9:30. You have up there the link to the textbook and your first assignment. This is going to be emailed to me or preferably submitted to Blackboard by midnight on Sunday. All right. So 11:59 p.m. Sunday night.
Oh, where do we need to upload this?
Either on Blackboard, which I gave you a link to right up here. So if you are on the Blackboard class, this will be under Unit 1 on Blackboard.
Okay. Oh, this assignment is different from.
No, it's the same. This
discussion?
assignment is the same as on Blackboard. I just copied it into an email for people who don't have access to Blackboard.
Okay, the discussion is the different thing, right?
Yeah, that's different. I don't care if you do that.
Okay.
Yeah, this is the second thing inside of Unit 1, and it matches this identically. This is the exact assignment. Answer those questions.
Okay.
So preferably, if you're on Blackboard, submit that answer in Blackboard. But if you're not on Blackboard, email it to me by midnight on Sunday.
Good.
That means between today and Sunday, you should be reading chapter 1 from this book and answering these questions. Everybody good with that?
Yeah.
All right. And nobody's going to turn it in late, because I don't want sob stories on Monday morning like, oh, I was busy the last 6 days and that's why I couldn't do my homework. Find some time. You're all adults. Do some time management. Figure out when you can set aside a couple of hours to do the reading and do the homework, and we'll all get along just fine. I don't like excuses, so just figure it out. And then make sure you're on the Slack channel. So hopefully I will see everybody's favorite food, which I'm already seeing a pattern of biryani. But I'll see that sometime early in the day today, proving that everybody has access to Slack, because I will put stuff up there and you will be accountable for things I put up there. So make sure you are setting it up to get notifications, or at least making it a point to look at Slack once or twice a day, just like you should be checking your email. All right, any other questions about any of that stuff? Are we clear what's happening between now and our next class on Monday? And everybody's going to submit their homework assignment to me by midnight on Sunday?
Sure.
Yes, Dr. Lichtman.
Yes, sir. All right. But like I was saying a few minutes ago, make sure you do ask your other professors when you have teachers other than me, what their preference is for format and stuff like that, because you will have teachers that are picky about stuff. Most of the teachers are not, but it's still worth clarifying. All right. So let's get back to all right, so let me here, I guess I can, you want me to go ahead and answer these, or are we pretty confident in our conversions? Does anybody want me to do the conversions, or do you pretty much know whether you got it right or not?
It's better if you can walk us through. Otherwise, I may have to relook the videos for me, at least personally, Dr. Lichtman.
All right, so I'll do them quickly. So first one, convert this number from base 2 to base 10. Okay, so this is the number. This is the ones place, the 2s, the 4s, the 8s, the 16s, the 32s, the 64s, the 128s place. So this is 128 plus 0 times, so this is 1 times 128. Zero times 64 plus 1 times 32 plus 1 times 16 plus 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. So that's 1 in the 128th place, 0 in the 64th place, 1 in the 32's place, 1 in the 16's place, 1 in the 8th place, 0 in the 4th place, 1 in the 2's place, 1 in the 1's place. So then you type that into your calculator and you come up with 187. All right, so that's the first one. Everybody's good with that? So the first several of these uses that same pattern, going from a different base to decimal. Remember, we looked at 2 patterns last class. So we're going to convert this number from octal base 8 to base 10. So I'll put some spacing in here now for these. So this is the 1's place, the 8's place, the 64's place, the 512's place, and the 4096 place. So this is 4096. This is 512. This is 64. This is 8. This is 1. This is 2 times 4096 plus 7 times 512 plus 3 times 64 plus 3 times 8 plus 4 times 1. So we have a 2 in the 4096 place, a 7 in the 512's place, a 3 in the 64's place, a 3 in the 8's place, and a 4 in the 1's place. Type that into the calculator and we get 11,996. All right, so that's that one. Next, same pattern, but now you needed to know about that hexadecimal conversion thingy. 0 through 9 and A through F for bases above 10. So A, B, 1, 4, F is actually going to be a 10, an 11, a 1, a 4, and a 15. And this is the ones place, the 16s place, the 256 place, the 4096 place, and the 65,536 place. This is 65,536. This is 4096. This is 512. All right. Oh, it's 256. 256. 16. And the ones place. This is 10 times 65,536 plus 11 times 4096 plus 1 times 256 plus 4 times 16 plus 15 times 1. So this is a 10 in the 65,536 place, an 11 in the 4096 place, a 1 in the 256 place, a 4 in the 16s place, and a 15 in the ones place. Pop that into the calculator and we get 700,751. All right. Now we're to this one. This switches our pattern. We're going from decimal to another base. So convert this number, 35,728. From base 10 to base 16. So this is the one where we divide by 16 over and over again. And we get 2,233. And this had a remainder of 0. We divide this 2,233 divided by 16 is 139. 139 times 16 is 2224. That's a remainder of 9. Right, 2224. So 24 to 33 is 9. 139 divided by 16 is 8. My eye is not working very good this morning. I times 16 is 128. That's a remainder of an 11. 8 divided by 16, 16 goes into 8 0 times with a remainder of 8. And remember, this 11 is actually a B. We read this from the bottom up, so this is 8 B 90. Last one. Convert 591 in decimal, which is base 10, to base 4. So this was to really drive the point home that these patterns work regardless of whether the base has a name or not. All right, so we're going to start at 591. We're going to divide it by 4. Gives me 147. 147 times 4 gives me 588, so a remainder of 3. 147 divided by 4, 36.75. So this is a 36 with a remainder of 3. 36 divided by 4 is 9 with a remainder of 0. 9 divided by 4 is 2 with a remainder of 1. 2 divided by 4 is 0 with a remainder of 2. So this is 21033 in base 4. All right, so that should have been all of the questions. So any question about any of those? Okay, so then the last thing. I had this slide here, start here, why octal, why hex, and then I said shortcut conversions. So let me actually, let me just take these 2 slides. Well, we'll start off after this. So we asked the question last time, we were talking about why we use these different things. Decimal makes sense. Human beings, 10 fingers, 10 toes. Binary makes sense. Computers, zeros and ones, on and off. So those make plenty of sense. We talked about hexadecimal at the end of last class as to why we use hexadecimal. And we decided, well, you know what, as you have larger bases, they allow you to represent large magnitudes and smaller footprints. So that's why, like, hexadecimal we use for memory addresses. So we use base 16 for memory addresses because it's a smaller footprint value than a base 2 number would be for that memory address, for example. And why do I say that? Is because in computers, the way memory addresses work is they work like you live on one big long road. All right. Human beings. So a lot of times folks get intimidated by computer memory addresses because they see the hexadecimal number and it scares them, right? They look at it like, oh my gosh, this, something like this. If you see a 0x12ab EEF 3, something like that. If you saw that on your computer screen, you immediately get intimidated because that looks scary. Okay, well, what we've done this last couple of classes is we've learned how do we turn this scary number that looks very foreign because it's in hexadecimal, how do we turn that into a decimal number, something that looks more familiar to us. Now, even if we turn that into a decimal number, it's still going to be a large decimal number, so it'll be kind of a scary big number, but it'll be a number that doesn't really look intimidating because it doesn't have these extra like letters and crap like that in it. But where I want to really close the gap here is many people, they view memory addresses as being difficult, being confusing, being intimidating, whatever it is. Keep in mind, and I mentioned this last class, that computers are far, far, far simpler than human beings are in real life. Okay, so all of you, you have a home address. You have a couple of different addresses, right? You have an address that's more local right now, but you have your home address. So human addresses have what? There's a street number. Well, there's a house number. Then there's a street name. Then there's a city. There's a state. There's a country, right? Because a lot of you, your home address is not in this country. So you have 5 different pieces of information at least that allows somebody to figure out where you are on the planet. All right. Computers have a one piece of information. Okay, when you have your computer memory, everything lives on one big long street. So you don't have to know what the street name is. You don't have to know what city it's in, what state it's in, what country it's in. You don't need to know any of those things. All you need to know is what house number it is. Is this the piece of information stored at house 1, at house 2, at house 3, at house 1, 2, A, B, E, E, F, 3, 4A? Make sense? So addressing in computers is just one gigantic road, and we're just numbering the storage locations along that road. And it just happens to be, if you have 16 or 32 gigabytes of memory, we're going to be talking about those number conversion, size conversion stuff next week. But if you have 32 gigabytes of memory, that's a lot of houses. That's a lot of houses that live on that one street. So we're going to need a lot of values to represent, to index those houses, and that's why we use numbers to pull that off. All right, so it makes sense to us why we use a larger base like base 16 to represent those numbers. But my question would be is, why did we choose base 16 instead of, for example, base 20?
It would be easy, Dr. Redman, for conversion, because at the end it should be in binary.
Okay, so you're right. In the end, we need to have a, so really, let me just take away from what you said. It's important if we're dealing with computers that we ultimately can get the values into binary, right? That's a true statement. You agree with that?
Yeah.
Okay, so why base 16 instead of base 20 for memory addresses, for example? So one thing you said is, you said it is important to be able to conveniently get any numeric value in a computer to binary. That's important. Okay. Well, why is 16 better than 20 for that? Why is base 16 better than base 20 for that?
16 is easier to convert it to binary.
Okay,
instead
why?
of 20.
Why is it easy? Why is it easier? I mean, based on
Because it's a multiple of 2.
Okay, so right off the bat, we say, well, okay, base 16, it's a power of 2, so that seems to be more compatible, right? Okay, but if I asked you to convert ABC 1, 2, 3 from base 16 to base 2, based on what we've learned in class so far, what we first do is we take ABC 1, 2, 3 from base 16 to decimal, then take the decimal number to binary. So we would have to do 2 different types of conversion, right? Based on what we've learned so far. Okay, but your speculation is that since 16 is a power of 2, maybe there's a shortcut. And here's the reality. In base 16, all the permutations of 4, well, let's see, all of the possible hextets that's 0 through 9, A through F, can be fully represented in 4 bits. A 0 is 0, 0, 0, 1, dot, 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 and F is 1, 1, 1, 1. And then everything in between. So you can represent fully and completely all of the 16 possible hextets in hexadecimal using exactly 4 bits. No more, no less. You need 4 bits to fully represent everything. It's a perfect fit. All right. Similarly, why octal? In base 8, all of
3
the
bits.
possible octets 0 through 7 can be fully represented in 3 bits. 0 is 0, 0, 0, dot, dot, dot. 7 is 1, 1, 1. All right. So why did we pick octal and hexadecimal? It's because in binary, we can use those to represent the 4-bit conversions, 4 and 3-bit conversions directly. So we don't have to go. Where's my scary number? Well, here, I'll just write something here. So for example, if I had 2AF in hex, I could just write that in 4 bits. 0, 0, 1, 0. That's the 2. The A is a 10. So that is a 1. I'll just put a space. 1, 0, 1, 0. And the F is a 15. This is the binary version of 2AF. 4-bit representation of 2, the 4-bit representation of A, the 4-bit representation of F. So you can directly convert it. You didn't have to go to decimal first and then decimal to the other base. Make some sense? So we've purposely chosen octal and base 16 to do their jobs. Now, as memory keeps getting larger and larger and larger and larger, and we're probably, we're a ways from this, but the next base that we can jump to without horrifically changing our mindset would be base 32. Because base 32 can be fully represented in 5 bits. All of the base 32 values can be represented using 5 bits. 0, 0, 0, 0, 0, all the way up to 1, 1, 1, 1, 1. All right, so that's specifically why hexadecimal and octal are popular bases. Okie dokie. So where we'll start next week. Now everybody knows what homework assignments stuff to do for Sunday night. So next Monday, we're going to say data sizes. That's where we're going to start. All right, questions, comments, concerns, bribes. Okay, well, I have to run to my meeting, so I am available via email. I'm even more available via Slack, so feel free to send me messages on Slack. I will look for everybody's assignments in by midnight on Sunday, and I will see everybody in class right at 8 a.m. on Monday. Sound good?
Yes.
All
Yes.
right. Well, you guys have a good rest of your week, and I'll see you on Monday.